Well, welcome back, everyone. I hope you've had the opportunity to work through the problems. What I'd like to do now is give you the solutions by working through them as a group. So the first thing I gave you was this table of the 1,944 men in our Framingham study, of which 843 died. Now, you can measure the cumulative incidence. The estimated risk of death among those people would be 843 deaths divided by 1,944 total men in the study. You could do the same calculations for females. You had 2,490 females followed for 24 years, and 707 of them died. Their cumulative incidence, their estimated risk, would be 707 divided by the 2,490. And what I asked you to do first is to compare those two, either by taking their ratio, calculating a risk ratio, or taking their difference, calculating a risk difference. So for the risk ratio, you would be comparing a risk of 0.43 among men, 43% of the men died during the 24 years of follow-up, to a risk of only 28% among the women. Only 28% of the women died during the 24 years of follow-up. If you take the ratio of 43% divided by 28% and calculate the risk ratio, you'll come up with a value of 1.54, meaning that the risk of dying for a male is roughly 1.5 times that of a female when they're followed for 24 years based on this data set. Now we can measure the difference in those risks. We could calculate a risk difference. We could subtract the 43% risk that the men had, and from that we could subtract the 28% risk that the women had and get a risk difference now of 15%. How we interpret that is that a male's risk of dying during 24 years of follow-up is 15 percentage points higher, greater than that of a woman. We have to add 15 percentage points to the 28% risk of women have to obtain the 43% risk that the men have. So that's how you'd measure risk difference in this case. Now, what if you wanted to measure odds? Because the last thing I asked you to do was measure the odds ratio in these data. Well, now we have to measure the odds of dying for men and the odds of dying for women. Among the 1,944 men, we had 843 deaths and 1,101 non-deaths. So the odds of dying would be 843 divided by the 1,101 non-deaths. For the women, we had 707 deaths, 1,783 non-deaths. Their odds of dying would be 707 divided by 1,783. Remember, odds are pot over non-pot, deaths over non-deaths. Well, if you go through the calculation, that means the odds of dying for a male is 77%. The odds of dying for a female, a woman, is only 40%. You could build a measure of association by dividing one of those by the other, calculating the odds ratio. 77% divided by 40% gives you an odds ratio of 1.93. How we interpret that is we say the odds of dying for a male is almost twice as big as the odds of dying for a female. It's a ratio measure again. Well, that's hopefully gives you some examples for calculating by hand odds ratios and risk differences. And later on in this sequence of lectures, we'll be showing you how to do this in Stata. But before we do that, I'd like you to do one other problem set where you calculate not cumulative incidence, but incidence rates of dying for men and women from these data. And that's what we'll be doing next.